In this video, we're going to be looking at features of inverse functions. So you should already be familiar with inverse functions, so be able to graph it, change the equations around, and be able to find an inverse function from a function, and then also restricting the domain. However, these are just some other features which we haven't talked about yet, which are useful for calculating questions. So the first is the features of inverse functions. So you have a function here, let's say fx, and you calculate the inverse, f negative 1x. Now, if you calculate the inverse here, and then if you calculate the inverse of the inverse, you will get fx again. So inverse, and you will get fx. So what I'm trying to say here is if you get f negative 1 of f negative 1x, you will get fx. So what it's from. So that means, well, you can see that in the reflection graphically. If you have a graph here and you're reflecting a line y equals x, so you have the line here and then you reflected it, so it goes like that, and then you reflect it back, you're going to get the original equation. So that's useful with regards to an inverse and its function are related in that you can keep taking the inverse and you'll swap back between those two functions. So with regards to this next equation, what I'm trying to say here is I'm talking about composite functions. So if you remember, like the fog, the goth. So here is, we'll take f of x, and then when we take f of g of x. So if I'm saying that g of x is equal to the inverse of fx, so here we have gx is equal to the inverse. So we're replacing x with the inverse. So remember back to composite functions. Then this is just always equal to x. And also if the inverse is on the outside, then you put the function in the inside, then it equals x. And the reason why it doesn't matter the order is just because what we talked about before about how the inverse of the inverse is equal to the function. So here we have, so you can have the inverse on the outside or the inverse in the inside, and the function on the inside or the outside. However, when you have the composite function, it always equals x, no matter what it equals, no matter what the functions are. So we'll do a quick example. We'll take a function fx is equal to e to the x. Then its inverse is equal to log e of x. We found that by going x is equal to e to the y, and then y is equal to log ex. So you have these two. So finding f of f negative 1x, this is equal to e to the log e x. Now the log e and the e so they cancel and we get x. So it shows here. And then if we take it the other way around, we get log e to the x. We can bring x down and we get x times log e to the e, so that just equals x. So that is useful when looking at composite functions and you know that one's the inverse of the other, then it's always going to equal x. Now when you're trying to find the intercept of a function and its inverse, and when you're graphing it, it's useful that if fx and f and the inverse intercept, it's always on the line y equals x. And why is that the case? Well, let's say if fx is equal to 3, 2, then f negative 1x is equal to 2, 3. So obviously these aren't the same. But if fx is equal to 2, 2, swap x and y, the inverse is also equal to 2, 2. So they both go through the point 2, 2, and so they'll intercept at that point. Then if you have any value here which is the same, let's say AA, then the inverse is always also going to equal AA. So if A equals A, they will intercept. And that's why it's along the line y equals x, because that's when y and x are equal, such as here. This is useful when you're graphing, and then it also has useful applications for finding it when they do intercept. Because the typical way you find when two functions intercept is you let them equal each other. So this would be the typical standard way. fx is equal to the inverse. But now we know that it has to be on the line y equals x. So we can say that to find this intercept, we can just go that fx is equal to x, or f the inverse is equal to x. And then that x value will tell us, or the x values will tell us when they intercept. Then once we find the x values, so let's say we know x is equal to a, therefore y is equal to a, because x has to equal y. So rather than having to sub it back in, we can just automatically know once we know the x value what the y values are, because they have to be the exact same values. So if we have a graph here, we'll see this. We'll graph y is equal to x squared when x is greater or equal to 0. So that looks like that. So y is equal to x squared. Then if we find the inverse when x is greater than 0, the inverse is y is equal to the square root of x. And when we graph that, we see that they intercept at the line y equals x. So whenever y equals x crosses, whenever the parabola crosses this line, then the inverse also crosses it as well. And then there's the 2 points here. So the first point here is 0, 0. The second point is 1, 1. So we can calculate that by going x squared is equal to the square root of x, and then solving. So you could minus it to the other side, you get x squared minus the square root of x is equal to 0. Then x, you can take square root of x out. x3 on 2 minus 1 is equal to 0. Therefore x is equal to 0, x is equal to 1. And then you can sub it back in and you find that y is equal to 0, y is equal to 1. But if it was a really long equation, so let's say fx is equal to 3x squared minus x plus 4, then the inverse could start to get a bit nasty. And then if you let it equal the inverse, it could be hard to solve. So sometimes it would have been easier, and if you're doing it on the calculator, to just go fx, or one of them, is equal to x. So you could just say here that x squared is equal to x squared minus x is equal to 0, x minus 1 is equal to 0. You can see the numbers here a bit easier. So x is equal to 0, x is equal to 1, therefore y is equal to 0, and y is equal to 1 at these corresponding points. So that is useful when graphing. So whenever you see that the line does cross, you know that it has to intercept here. When you're drawing the inverse, you have to know it has to go through that point. But it's also useful for finding that if you do have to find the intercepts, you can just let it equal to x. And then when you know the x values, you know that the y values have to be the same.